indexing is a way where you apply different filters using comparative operators such as greater than, less than, equal to, double equal to, and so on, and try to get a new series or data frames. So let's see a few examples of Boolean series and indexing on a single condition and on multiple condition. Now let's start with single condition, but before we start with some examples, let's load some data sets, like couple of data sets. There is a popular data set called as iris data set, and I call it as id is equal to pd dot read underscore csv, and here is the link of the data that we have. I'm going to copy and paste it here, and I'm going to say id.head to check the first 5 rows of this data frame id. Okay, there you go. And at my first glance I see that the first row is occupied as a header, so I'm going to use a parameter called header is equal to none, and once I do it and run it, I see that the column name is also different. So since I know the names of the columns, let me change the column names. So it's going to be sepal length, sepal width, sepal length, sepal width. Okay, let me first do all the quotations. So I'm going to create a list of each of the columns. So 0, I want to replace it with sepal length SL, and then SW sepal width with 1, then petal length with 2, and petal width with 3, and here whatever 4 we have, I wanted to call it as species. Alright, and I'm going to use a parameter called names and is equal to calls, and I'm going to run this cell again, and there you go, I have replaced it with different names here as header names. Okay, this is what id is, right? id data frame. Let me load another data frame which is wine quality, which I have already have in the folder, uploaded to the folder in the Pandas in the Google Colab. So I'll call it as wine data. wd is equal to pd dot read underscore csv, and the file name is wine quality and dot csv. Okay, and let me verify it by using dot head method to check the first 5 rows. Okay, there you go. I have wd wine data, a data frame, and also id, another data frame. Okay, let's get to the examples. Now we know, so let's say wd, right? wd is a wd is a data frame, right? So if I say wd, I get this. Now if I use the square brackets, and inside this, if I say, like, let's say ph, right? This is ph, and if I say p and capital H, what will happen? You'll get a series. Okay, you'll get a series. Now if you want to make this as a data frame, we have already seen, we'll use another set of square brackets, and there you go, it becomes a data frame. So we know roughly what the square brackets stand for, what is the use of it. Now there is one more use of it. What we are going to do is, we are going to fill it up with Boolean series. When you fill it up with Boolean series, what you get is a data frame. Okay, so what is a Boolean series, and how do you obtain a data frame? Let's see that. For that, what I'm going to do is, let's get back to our data frame and let's check the first 5 rows of this. Now let's say I want to put up a condition here, wd of, maybe let's take residual sugar. Here I have residual sugar, right? I'm going to paste this, and I'm going to say greater than 10. I'm going to remove this. I'm going to run this. So I got a series. What this series says is, when I said WD of residual sugar greater than 10, the column residual sugar, each and every value of it is getting iterated and checking if it is greater than 10. If it is greater than 10, it returns true. Otherwise, it returns false. So this, the series obtained here, this is the series, right? You can verify that. How do you verify that? Simply use type and verify it. It's a series, Pandas series. Now this series obtained in terms of true or false is called as Boolean series. Alright, this is called Boolean series. And now what I told you before, okay, if you insert this Boolean series inside the data frame, I just showed you, right? I mean WD, and if I use this entire thing, okay, in this square brackets, what will happen? You are going to get a data frame with values, residual values, with this condition in the residual sugar greater than 10. See, all the values are greater than 10. This is called Boolean indexing. Okay, so to make it more readable, I'm going to show you again the same thing what I have done in more readable form. So what I'll do is filter is equal to WD of residual sugar greater than 10. Alright, I'm saving this or assigning this piece of code to a variable filter, and then what I'll do is WD of FILT filter, and there you go. Oh, 1 second. There is a double quotation here. Okay, and you can save this. Maybe let's say df1 data frame 1 is equal to WD of filter1, and you will say df1 dot head. So you got the same result with data frame whose residual sugar values is greater than 10. Okay, so this is a simple example of a single condition. This is a single condition, right? This is only one condition. Okay, now let's take example 2. Okay, the same data WD.head, or in this data frame, you see in the column type there are white and red, but let me confirm that. Let me confirm by checking how many unique values are there in this column type by using a method called unique. Okay, let's check it. So there are only 2 unique values, white and red. Okay, now let's go to this example 2 with a condition which says WD of type is equal to red. Okay, so I want this condition, and you know what, I want to assign this to a variable filter. Okay, and then I'm going to use this in this data frame with filter. So here, there you go, I got a data frame wherein the type is red. So type is red, so all the red wine data is obtained. There are so many rows, 5910 rows of data, and I can simply say df2 is equal to this and check the data using the head method. There you go. So these are the 2 examples where we have used a single condition using the comparative operator and here double equal to, and we have checked or obtained a new data frame. So this is Boolean series, right? And once you put the series inside the data frames between the square brackets, you get a data frame, and it is called as Boolean indexing. Now let's go to multiple conditions. So it is not just limited to single condition, you can do multiple conditions, and for that there are other additional options such as and, ampersand, or not operators. These are the logical operators that you can use. Apart from that, there is a method called Easein, which I will show you. So let's go to example 1. So let's say filt1 is equal to, I'll use the same thing here, same condition, which is WD of residual sugar being greater than 10. Okay, there is a double quote, and yeah, and filt2 is WD of type being red. So I'm interested in red wine with residual sugar greater than 10. It's as simple as it is. So then the filt would be filt1 and filt2. So this is filtering red wine with residual sugar greater than 10. Now if I use this filt inside this data frame WD, okay, and if I run this cell, what happens? I'm going to get red wine, all the red wines, and there are only few red wines whose residual sugar value is greater than 10. As simple as it is. I can save this to a third data frame df3, and I can check the first 5 rows. And what if I use, instead of and, if I use or? Let's check that too quickly. Okay, instead of and, if I use or, then what it would be? It would be, it could be a red wine or white wine, or it could be a residual sugar greater than or less than. So this or this to be true. If any one condition is true, you're going to get that true. So it is as simple as it is. Then let's see another example where we use not operator. Now let's say filt filt1 is equal to WD of type same residual sugar greater than 10, and filt is equal to, I'm going to say not of filt1, and I'm going to use this and see what happens. There you go. So you're going to have all the columns or rows of data where the residual sugar is not greater than 10, that is less than 10, and it is evident from here. You can see here. And another example, quick example would be what? Let's say filt2 that we saw previously as type equal to red, and if I say filt is equal to negative of filt2, and if I use this in filt and run this, you see that I have got all the data of white wine. Why? Not of red wine. Filt2 is of talking about red wine. Not of red wine is white wine. That's what you got, all of them. Now let's quickly see an example where I use these 3 conditions, filt1, filt2 and filt3. Let's say this is filt1, then the filt2 that we have used here, and filt3 probably I'll say pH greater than 3.3. fine. So, and filt is equal to filt1, I'll use 3 conditions with and between them. Okay, The first one is filter1, second is not of filter2, and third one is filter3. Okay, so and I'm going to use this WD in between this data frame, and I'm going to use FILT. Let's see what happens. So what we are doing essentially is we are looking for a data frame which contains rows of data such that the residual sugar is greater than 10. This is the condition, and not of filter2, and all the data are of type white wine, not red wine, because not of red wine is white wine, and also whose pH is greater than 3.3. So there you go, we have like 146 rows of data wherein the type is white, residual sugar is greater than 10, and pH is greater than 3.3. right, there you go. So this is how you can use. You can as well save this to, let's say, df4 is equal to this, and say df4 dot head, right. These are the first rows that you get using dot head. So these are some of the examples of multiple conditions. Now what we can do is use Easein method. Now what is the Easein method? To understand that, to when to use Easein method, let's take a look of your iris data, right, id dot head that we had, iris data that we have loaded it before in the very beginning. Now in here in this in the species column, like id of species, and if I say unique, and I want to see what are the unique values in this. So all these three values, iris setosa, iris versicolor, and iris virginica, are called the classes. So if I consider species as a label, the label species has three classes. Okay, class 1, class 2, and class 3. So that is the meaning of it. So whenever a label has multiple classes, and you want to filter based on a particular class or more than one particular class, you can use Easein method. What am I talking? Let's see. Now I'll say simply LOCS, and then I'll say I want to see these two classes. I'm going to create a list of these two, okay, and I'm going to say ID of species and dot Easein and LOCS. Let's see what happens. I got a Boolean series. Okay, I got a Boolean series, and if I save it to if I just do ID again and then run it, I'll get a data frame. So these are the data frame wherein you find the species, these two classes, okay, and it is filtered, and we got the data frame. So this can be confusing. So what you can do is you can assign it to a variable, then you can pass it or place it between the square brackets of a data frame to get this, and you can save it to a data frame, and finally you can verify it if it is working, and there you go. So this is how you can use Easein method. Now let's quickly see another example of this WD data frame that we have. So we know that the type has two unique values, right? Red and white. Okay, now let's apply this for red. Let's say LOCS is equal to red. Okay, and then we'll say filled is equal to WD of type dot what did we do? We are using Easein method, right? Easein LOCS, and we'll say WD of filled and see what happens. So there you go, you got this data frame, nice little data frame with only red as its type. Now if you were wondering why did we not get a series, because we used the square brackets here. If we have used if you have not used this, you will get an error. So we got this, and here what we did is we passed this filter inside in between these data frame, and we got this. So if you just check this one alone, all you get is a series. Now you're assigning it to a variable, and then you're passing between the data frame, and you'll get data frame. Okay, data frame with type being only red. Anyways, this is what is multiple condition method, and the dot Easein method. Now let's go to another example here, which is called between method. Now let's quickly see what the first 5 rows of an iris database look like. Okay, now I want to check if I want simply to check, see what the sepal width is there, right? Sepal width being greater than 3, and also it being sepal width being less than maybe 5. Okay, I want to check all the values or create a subset of data, okay, with this condition. So typically what we have learned, we create filt1 is equal to ID of sepal SW, right? SW being greater than like what, 3, and then I'll say filt2 is equal to ID of SW being less than 5. Okay, let me take this off, and then I'll say filt1 is equal to filt1 and filt2, and I'll pass this in the ID, and you'll get this, right? So you got all the values where it is greater than 3 and less than 5. There are 67 such rows. Now this is one way, but you can also use something called as between method. Okay, there is something called as between method, wherein what you can do is you can simply say filt is equal to, okay, let me do it in another cell. Okay, filt is equal to WD of sepal width, that's what we were looking, right? Yeah, sepal width. Okay, dot between 3.0 and 5.0, right? Yeah, and then simply say WD of FILD. One second. It's not WD, it's ID, sorry. And again here it is ID, iris dataset. There you go. I got a data frame same as this one, with all the values between 3 and 5. I mean including 3 and 5, of course. So you can use dot between method when you have a simple condition like this. So this piece of code is simplified into 2 lines of code using dot between method. Now after this method, let's see use of .loc. Okay, let's say here, let's say COLS, I want to write a couple of columns called alcohol and maybe quality. Okay, and I'll say WD .loc, and I'll say okay, and I also want a filter to be applied. Filter is equal to WD of type is equal to red. Then I'll say WD .loc. The rows are going to be the filter and the columns are going to be the ones. There you go. I have got all the red wines, you know, with the alcohol and quality as my columns. I can use another condition also. I can use a residual sugar greater than 10. Whatever condition you want, you can use it. Okay, so I can use this way to obtain a new data frame. Now let's see another example where we see column to column comparison. Okay, what is column to column comparison? It simply compares values of one column to other. So let's say WD.head is like what? Okay, let's compare, I don't know, these are not very close enough. Yeah, probably this citric acid with sulfates. Okay, so I'll simply say WD of citric acid greater than WD of sulfates. Okay, so what's going to happen? You're going to get a Boolean series again. Wherever there is true, it will give you true. Wherever there is false, it gives false. So I want to see if there are any true values in here at all. Yeah, there are a few true values, but if you generally see like this, you seems to feel that there are only false, then that's fine. So what I want to do is I want to call this as FILT filled, since this is a Boolean series, and what I'll do is I'll place this to a data frame. Okay, and I'll obtain a data frame, as simple as it is. So this is a data frame wherein I'm comparing two columns, citric acid and sulfates. Now if you see, the data frame that I obtain will have only the rows wherein this value of citric acid is greater than sulfates. If you check the values, all these values of the citric acid are greater than sulfates, column wise. See, 0.48 is greater than 0.39, 0.56 is greater than 0.51. So this is column to column comparison, and you are creating a new data frame. Okay, you can just assign it to dfi, and you can say dfi dot head and verify the first 5 columns.